Hello there, everyone. Thank you all for joining. My name is Matt. I'm a developer advocate here at JetBrains. And today I've got the pleasure of introducing Jeremy Miller, who'll be joining us in a moment to talk about Wolverine, which is a new messaging library that you're going to want to try out. Before we bring on Jeremy, however, a couple of little bits of housekeeping. Firstly, if you have any questions during the webinar, please add them to the chat box and we will get to them either as we go or we'll answer them at the end. Anything which we don't get to, we will pick up and add to a blog post after the session is concluded. Of course, this is being recorded. You can see it on YouTube right now, and the recording will be made available afterwards. And again, we will make this available via a blog post and let you all know where the links are at the after things are all done. So that's it from me. Now it's just a case of bringing Jeremy on and going to introduce Jeremy. Hi there, Jeremy. Hope you're ready to show us all about Wolverine. Just to say that Jeremy Miller is the Senior Director of Software Architecture at Media Analytics. And today you're going to be talking about Wolverine, I believe.
Yes, I am. It's been brewing for way too long. I'm excited for this.
Excellent. Us too. I don't know anything about it either, so I'm looking forward to seeing this. I'm going to leave this in your capable hands then. Thank you.
All right, thank you. Hey, first, let me start by thanking JetBrains, both for hosting this webinar and also just for all the support they give to open source tools. A lot of the code you see today was written with JetBrains Writer using an OSS library. I have a license through my company today. That's awesome. But again, thanks to JetBrains. All right, so Wolverine itself. This is not exactly a new library or framework, even though it's had a lot of new work in the last 6 months. This actually started all the way back in 2015 as a project called Jasper. That's kind of mostly languished since then, but it's built on about 10 plus years of experience with asynchronous messaging, both with other tools. Wolverine actually is kind of a descendant of a much older tool that was in production at a former employer called Fubu VC and Fubu Transportation. So there's a lot of lessons learned along the years that have gone into this. Now, just a few links just to see if you want to follow. Just got lucky, got the documentation updated today. So wolverinefx.net. There's still going to be plenty of holes in the documentation, but we're working on it. And then I'm going to be showing Wolverine in conjunction with another project called Martin. That was also on JetBrains webinar pretty recently. So there's a link to Martin as well. And then finally, you can follow me on Twitter while Twitter still exists. All right. So the W's and H's of what is this thing? It's a little bit more than just a messaging framework. The big thing about it is a way to execute messages within your system. Messages in this case could be just thinking about the role they play. It could be a command. It could be an event that you want raised, that you want handled somewhere else. They could be invoked inline completely locally, or we could be using Wolverine as an asynchronous messaging framework to communicate between applications or between processes. All right. Why you care about Wolverine. This is a crowded field, especially in the .NET space where we do a lot of enterprise development. The advantages of Wolverine, this is very much designed for grown-up development. And what I mean there is it comes out of the box, hopefully with all the instrumentation you need to run in production, a lot of robust error handling, test automation support to make this possible. So this can be not just developed with, but also tested. And really just anything you need to be productive in a tool like this. Now the how, I presented this to some of my team, my architecture team yesterday, and somebody asked, why would I bother to use this, right? What are the advantages over the tools we already have today that are already working? And what I'm going to try to prove today is one of the advantages of Wolverine is it results in much lower ceremony code. You are much more able to work only with the code that's germane to your application. The business logic, the data access. All the other things in infrastructure, we're going to try to get out of your way. Now, also trying to be faster. I'll get into this a little bit. Wolverine takes a very different approach in its runtime architecture that I think is going to lead to better performance through drastically reducing object allocations and just the amount of junk that happens when you try to handle a message. All right, so it's time to jump into some code in just a second. Let's pretend for a minute that we are building a very crude ride-sharing application. So we decided to compete with Uber or Lyft, and we're going to start writing a new system for that. Obviously, I don't know anything about that problem domain except as a customer. And if there are any real Uber developers or Lyft developers watching this, they're going to be laughing at this, but that's okay. So jumping right into code, let's take the use case. I am on vacation with my family, likely where this summer, and we used Uber quite a bit to get around. We were in San Diego. So I pull out my phone. I want to go request a ride. I'm going to say, hey, I've got an existing account. I want to be picked up here, and I'm going to go to this place. I'm going to send a message in to through the web service to, hey, I want to ride. So finally stepping into code. So a couple pieces. I'll look at how Wolverine is configured in just a second, but let's dive straight first into the actual message. So Wolverine, at this point, Wolverine is supporting .NET 6 and .NET 7, which means you're perfectly capable of using C# records or anything in F#, right? So simple message. I'm going to tell you what the ride ID is up front. This is who I am. This is where I'm starting. And this is where I'm ending. Simplistic message handler. Now switching over to Wolverine. So this is the code that's going to handle the request for ride command. We're going to start, and I'm purposely using a longhand form of this, and then we're going to move to try to simplify it through some other Wolverine things. But in our handle method, we're going to create a new ride document. This will be an entity that we're going to persist. I'm using Martin. Martin is a library that allows us to use PostgreSQL as a document database. Using it here specifically because, well, admittedly, because I'm also one of the people behind Martin. And Wolverine is purposely being built to make Martin even better, but it's also easy. So we're going to create a piece of data, we're going to store a new entity, and as part of this, when I request a ride, now there's some other actions that the application needs to take. When a ride is requested, go figure out what drivers are nearby who could possibly pick this up. And it's not unlikely that's going to be a very slow operation or an expensive operation. So we don't want to tie down our web server in line waiting for that operation. Instead, we're going to save off the ride information and we're going to raise a totally different event message, this ride requested, to let something else handle this in a background process. What we're seeing here, this message publisher, this is a service from Wolverine itself that is enabling us to just publish this new message in a local queue. We're not even going to bring in any kind of external messaging infrastructure yet. We're going to run everything in process. So all told, create a new entity, save it, publish a new message to be processed in the background, and commit the changes. So this is committing the unit of work, making the actual database commit. If you are experienced with asynchronous messaging, you're looking at these two lines of code that I've highlighted here, and you're a little bit in horror. You're probably making some kind of evil eye, warding off evil gesture, because you know this is a potential race condition. And this is something I have definitely experienced in real production systems. I just about 6 months ago helped the team unravel some problems with this. There is every bit the possibility that this asynchronous message could actually be processed before the database changes are committed. if I flip it around, and when I do that, when this ride requested event message is actually processed, the ride data may not exist yet. So everything blows up. Worse, it's not consistent. It's a race condition. You're going to be scratching your head. Why does this work sometimes? Why does it randomly blow up others? It's because it's a race condition. Now, other way around, this could also be problematic just when this fails. That's less problematic, but still. And there's always an issue of maybe this fails to enqueue. If we were publishing to external infrastructure, like we're going to use RabbitMQ in a minute, there's always a possibility that this would fail going out to RabbitMQ, and then we're still kind of stuck. Right? So this is a longhand form. Now I want to shift to some of the things that Wolverine does to make this easier. So the code I'm looking at right now, this is actually, and actually where that demo didn't get done. So this code I have highlighted, this is exactly an equivalent in functionality, but I want you to notice a couple things. And Wolverine's going to handle this for us. I'm still taking in the request ride command as my first argument. There is a naming convention, as you probably guessed. If it's called handle or consume to be backwards compatible with an older system, Wolverine's going to say, hey, this is a candidate to be a message handler. Some of you aren't going to like that. Some will. Just let me try to go with it for a minute. So a couple other things to notice. At no point do you see anything related to Wolverine itself except this one attribute that explicitly applies some middleware we're going to look at in a second. That's it. There's nothing else going on for Wolverine. This is actually a static method. So rather than having an instance that's created every single time where you're poking things through constructor injection, as we would typically do in a C# system, instead, we're going to call a static method. So there's just one less object being created. We can actually use method injection. So I'll show you in a second. Wolverine's actually going to push this. In this case, this is the Martin document session that we need to get at to store things. Now, sorry to keep hammering on this little tiny thing. Another thing we notice, this is a synchronous method. We're not doing any kind of IO here. There's nothing that needs to be asynchronous. So my method here can just be, I'm going to create the ride. I'm going to log it to be stored. And what I'm doing here, I'm using a Wolverine feature we call cascading messages. And this is something we heavily used in that older FUBU system I alluded to that was in use 8 to 10 years ago. In this case, this ride requested by returning it from the method here. If all of this succeeds, then this ride requested will be published afterwards. Okay. From here, I'm going to switch to, I want to take a look at how this is actually configured in your application to give a little more context. And then we're going to take a deeper dive into what Wolverine's doing. So moving to the setup, and I'm going to actually comment out quite a few things just so we can concentrate on what is important right now versus what isn't. And let's clean this up real quick. Okay, so pretty standard .NET 6 or 7 web API template. Hopefully a lot of you are familiar with this already, but we're going to start building up our application. This is not terribly important. That adds some extra diagnostics we might take advantage of. You got your normal application services. But then here, this is where we plug in Wolverine. Idiomatic .NET, or at least in the .NET Core era, the use Wolverine extension method, This is what we want to mostly use. And it's going to be directly on iHost Builder. It is not on Service Collection. There is a reason. Just kind of be aware of that. But if we're going to use Wolverine strictly as a local command executor, this is all we need. This will set up the automatic discovery, set up enough of the core services that we need, and gets us going. Now, I'm using Martin, so I'm adding Martin here. So I'm just saying, I'm grabbing a connection string from app settings off the side. I'm just telling it what Postgres database schema I want to use. This one's important now. We'll come back to that much later. This one's important. Adding on this to Martin, now we're going to set up some Martin transactional middleware support. And this is also setting Martin up as an outbox support for us. And I'll explain that in just a minute. Yeah, and a couple other things. I've just set up one route that is going to immediately delegate this one route. We're going to send the request ride command, and we're going to delegate right to Wolverine. So this iCommand bus, this is one of Wolverine's entry points. There's only really 3 that you're going to interact with, and they're all just broader forms of each other. But if you're familiar with the mediator tool, this is Wolverine's equivalent. And then finally, that's just some expanded command line support that's going to come into play in a second. All right. So just have you look at this one more time. We're going to use transactional middleware. We're going to call this method. Wolverine's going to call this method, pass in request ride and a document session. Somehow or another, this outgoing cascading message is going to be enqueued with Wolverine and sent to a local queue. So now let me give you a quick preview of something here. So I mentioned that we had some expanded command line options. That's actually from a sibling tool called Oakton. We've got new options at the command line within our application. One of the things I'm going to do is show you what Wolverine itself is doing. And I shamefully have a bunch of code warnings in our sample code. Just look away for a second. Okay. All right. So the code on the screen you see, Wolverine actually generates code at runtime, or can do it ahead of time as well. It generates code to wrap around your code. So this is the handle method in our application. And our dog Chewy is being a critic here. It's ugly code. I mean, it's code generated, so it's always ugly. Let me see if I can make it look a little bit nicer and explain what's going on here. Okay. So this object is generated at runtime or ahead of time. This is a singleton within your application. It is only created once. Every time a new message for request ride comes through, it's using this exact thing. Wherever possible, one thing, let's kind of look what's going on here. We're calling through the handle method. We're creating a document session from Martin. There's a little bit of mechanics going on, but what's happening here is it's creating a document session, but also enrolling in the outgoing outbox. So here's where we grab the methods coming out. We're telling the outbox, hey, there's a cascading message that's going out. This doesn't get sent yet. It's just pending. It's routed. We figure out what to do with it. It's just pending. When this saves successfully, then we're going to send that thing out. Okay, so back to PowerPoint world for just a little bit. right? So middleware strategy. Let's see. So I think you've all seen the Matryoshka dolls, the stacking dolls. These in particular were built by a Ukrainian craftsmen. So shout out to all my Ukrainian colleagues. The point here is this model is also often used as an analogy to describe middleware strategies. Thinking about, assuming you're a .NET developer, or if you're a Node.js developer, the express model, having maybe nested lambdas or functions to allow you to do things like apply transaction boundaries around an inner handler, or putting extra logging performance tracking around an inner handler, or validation. But something being able to enrich the execution pipeline and handle these kind of cross-cutting concerns outside of your core application code. This is an extremely valuable way to be more productive as a developer. Some people don't like this. And, it's too much magic, but those people write too much code. And their code is frequently obfuscated by having so much ancillary concerns like logging, security, validation, infrastructure junk surrounding the code they're really needing to write. So that's a great thing for productivity standpoint. It's a potential problem, though, from a performance angle. Go back to the code here. So there's not much going on here. But in a typical application framework that tries to use a middleware strategy, what they're generally doing is either creating lambdas, calling inner lambdas, coming back through the stack. That's a lot of potential object allocations. That is a potential performance problem. And to give him a shout out, Daniel Marbach from Particular Software has a blog series of all the outrageously smart things he has helped do to eliminate performance problems in a very different sort of middleware strategy. The older Fubu tool that Wolverine descends from, we had a very flexible middleware strategy. It's actually very similar to what In-Service Bus does today because they copied it. But we created all new objects for every request that came through to create the nested behavior. And you just blasted up the object allocations. You made the memory thrash hard. The garbage collector had to work. And you're just doing a lot of dictionary lookups. And you see where this is going. There's just a lot of fat. So Wolverine tries to allow you to have that exact same middleware kind of functionality, but do so without the crazy object allocations and the performance problems. And by doing this runtime code generation, I think we are completely sidestepping the performance problems that most application frameworks have today that enable some kind of middleware strategy. So have your cake with productivity, but still get to eat it by not screwing over your performance. Sorry. And then just another issue, anybody that's worked on taking ASP.NVC as an example, where you might be using a lot of action filters and ASP.core middleware, when you have an exception and it finally gets logged up to the top, your exception, your stack trace can be just buried with details of, I was in this totally unrelated middleware. I was in this other middleware. All these things that are totally unrelated to what the actual problem is because they just happen to be on the outside. And a developer who's not maybe very aware of what's going on, or maybe a very experienced developer that just didn't sleep that night, they're going to see one of these exception messages and see all this unrelated noise that has nothing to do with their problem. And they're going to go off looking in the completely wrong place, or they're going to miss the important detail that's hidden at the very bottom of the stack trace. It's a long-winded way of saying one of the things I definitely hope with Wolverine is we solve that problem with the ugly stack traces, because Things will go wrong. And when they do, it's awfully nice if you can figure out what's really wrong. Another issue, I talked about this being magic. The ride requested is automatically in-queued as a cascading message. Some people don't like the magic. They rather have it be explicit. I'm also going to try to say, my family dog has been really quiet all morning until right as we started the webinar. If you hear a background noise, that's him chomping on a dog toy. Getting back to that, if the framework can tell you, like it can here by showing you a preview of the code, hey, yeah, there's magic, but this is exactly what I am doing inside of it. My theory is that this makes the magic be okay. All right. Back to PowerPoint world. So a little bit more on that outbox idea. So using this inbox and outbox, inbox just means a listener. If I'm listening to a RabbitMQ queue, in the case of Wolverine, it will actually persist the incoming messages to a database until it's able to process it. Same thing with the outbox. That problem of I'm trying to make a database change and send a message at the same time, but the message depends on the data I'm saving. Everything has to be done in the right order, and they have to both succeed or both fail. At any point in this kind of asynchronous messaging world, we want things to be consistent. And as much as possible, we do not want any human intervention necessary to go fix problems that happens. So this inbox and outbox is really important here. It makes that save data, send a message, an atomic operation. They both succeed or fail together. In the case of Wolverine, it's a little bit of an eventual consistency kind of thing that you're actually saving the message body and all the metadata about how to send the message to the underlying database in the same transaction. By using Martin underlying, we tie into Martin a little bit. You're able to save everything in the same database transaction. And in the case of using Martin, you're even sending it in the same command. This makes the operation ordering work. Don't let that message escape out into the real world until the full operation actually succeeds. Coming down, there's some other advantages. The Wolverine outbox, it's a background process. It's running as a hosted service in your .NET application. It can actually survive process crashes. If somehow or another, and this always happens somehow, the operation goes through, succeeds, but somehow the system fails before the message can be sent out. Or maybe the external messaging infrastructure is temporarily unavailable. That's actually okay, as long as that operation succeeded and that that outgoing message got to the database. Wolverine will keep trying until that thing is sent out. Even if the process itself fails, when you restart the process, or it's able to fail, another process can steal that message back and send it on. That's a way to add a lot more resiliency to your system here. We do a lot of message batching with some of the transforms, or the transports. Doesn't necessarily have this in RabbitMQ, but if we're using Azure Service Bus or AWS SQS queuing, the outgoing transport uses message batching, sends a lot of messages at one time. So you're not necessarily, when you send a message, you're not automatically sending the message right at that very second. Instead, it's being kind of queued up locally, batched, sent out. So there's a lot of opportunity for things to go wrong. But again, if you're using a durable outbox, that message is not going to be lost until it can really be pushed to the downstream transport. And then finally, just calling this out, idempotency, which just means if you're using a durable inbox, if Wolverine is able to detect that, hey, I've already processed this message. I see a message ID that's already been processed. I can see from the database it's recently processed. I'll log it for you, but I'm going to discard it. We don't need to do anything here. That's important. That's in Wolverine as well. Okay, so we're talking a lot about Martin itself. That's the guy up here in the top left, the icon, and using Postgres. Just to let you know, Wolverine is absolutely usable without Martin. Martin is certainly usable without Wolverine. But that kind of durable outbox, Wolverine also supports Microsoft SQL Server and EF Core. Let me show you an example. I'm not going to run this, but let's look at, just to prove that it exists. Okay. I didn't actually push through to make sure that ran. Don't pay attention to that. But just say that storing a ride that we have an EF Core DB context at some point. So maybe in this case, I'm going to use the outbox from an MVC controller. So, there's a controller base, one MVC handler. I'm going to take in, this is a Wolverine supplied service. There's a separate Wolverine FX.entity framework core package. I'm going to pull down the RideDB context, but I'm going to use it wrapped in this service so that Wolverine can automatically enroll it in an outbox. So did the same kind of thing, really the exact same functionality. I want to persist the new ride, and I want to send out ride requested. So in this case, I'm marking it with the outbox. Hey, I want to publish this outgoing message. But because this is part of the outbox, nothing's happening here. It's just being kind of queued up of this should go out if it succeeds. And then finally, with a real clumsy method name, I'm happily open to suggestions. But the outbox here is wrapping the DB context and the outgoing message. Try to save the changes, and if they succeed, it's going to flush the queued up message and let it go out. So you have that consistency model of succeed or fail together. But anyway, the whole point of this is to prove Wolverine isn't hard tied to Martin itself. You can use this with EF Core because most .NET developers are not going to be using Martin, and EF Core is extremely common. There's another big point here. This has recently changed in the more popular messaging frameworks in .NET, but until very recently, their versions of an outbox were not usable outside of their own message handlers. If you really needed to use an outbox within a web service, you were kind of out of luck. You had to write your own, and that was really problematic. Wolverine right out of the box, it's a tiny bit more work than it would be with doing this inside of a message handler, but that kind of outbox, the durable sending, that's absolutely available to you inside of an MVC controller, a minimal API call, or just any random method in your system. That's potentially valuable. Okay. All right. So things go wrong very frequently. Maybe database gets overloaded, gets a little whiny, you get transient errors. Maybe we can detect that an error just can never be processed. And there's a few other things here. Let me dip into some of the troubleshooting or the error handling capabilities in Wolverine, excuse me. It's probably not going to be the last time I mess that up. So digging into the Wolverine setup here. Let me show you some of the options. So one of the most common problems you're going to have is all right. So this is going to be the system in the end. It's coding against Postgres. We can have occasional transient errors of database gets overloaded. Maybe there's timeouts. Yeah, that's actually a good thing. We're getting random database errors or timeouts. What we want to do is say this isn't necessarily saying that the message can't be handling. It's just saying there's a temporary problem. So what we might do is say set up a crude system of exponential backoff. Okay. So on the first failure, I want you to pause inline. This is inline. Pause it for 50 milliseconds. If it fails again, wait a little bit longer. If it fails a second time, wait even longer. And if it's still not, after all that, it's still not passing, go ahead and move it to the error queue. So what we're doing here, by doing this kind of retry with cooldown, it's enabling us to throttle the system a little bit. Because what you probably have is some kind of distressed resource, like a database, maybe a web service, something where it needs to maybe just get a few less things going to it, give it a chance to recover. So that's what we're doing here is we're purposely slowing down the system, the rate of messages are coming in. That's one thing to do. Another, sorry folks, let me look at my notes real quick. Yeah, so it's something that happened to me a couple years ago. Saying the matching here, let's re-queue this. Okay, so matching is a little bit more than just matching type. If you use a tool like Poly, this is going to look very familiar. It's going to look extremely familiar, even though it's not actually Poly itself. But what I want to do, this is something that happened to me a couple years ago. We had a system that at one point listened to incoming messages on a queue and then immediately kind of mapped and transformed and tried to call a web service to a third-party system for every message coming in. One thing that would happen with this third-party system is it was extremely easy to have it misconfigured in a way where it would completely knock the service out. You could tell from some of the error codes coming from the web service, you could actually tell that, nope, that system is in an invalid state and it will never publish anything. They will never be able to handle anything. But what would happen is we had a naive system of error handling where we just try to retry messages no matter what. So this would happen to us. It would retry the system. It would flood with failures. Everything would go to the dead letter queue. And people would have to go manually drag things out of dead letter queues. That's bad. If you get into that kind of situation, specifically to handle that problem, Wolverine has the ability to say, if I detect the downstream system it's just done, it's out of bounds, it's never going to work. What I can say is, I want to take this message, I want to immediately go stick it in the back of the queue, just go put it back there, and then I want to shut down this particular listener for 10 minutes and try to restart it with the idea that you're going to give production support some chance to go fix it. Let me see. And if you wanted to, you could actually do some kind of custom email action or text to let support know, hey, I detected this, please go fix it. Right? The point here being just, you got options. There's a lot of power here for error handling because things go wrong. Just a couple more things that I could do. I can detect that a message is completely invalid and it can never, ever be processed through the exception. I can tell Wolverine to just discard it. I can tell it to move to a dead letter queue. I can tell it to just log it and discard it and get it out of there. Okay. One other kind of important thing I wanted to look at. Here in a little while, we're gonna look at the usage of RabbitMQ. So for a particular queue, you can set up with a listener, but we may say we know that it's doing something downstream where it may be prone to failure. There's options here. This is admittedly heavily influenced by mass transit's API. The mechanics are very different internally, but I like the way they expressed it, so it does the same thing. The circuit breaker here is listening, kind of monitoring the activity of the messages in just this listener, this incoming queue. And if we get a too high of a rate of failures, let's see. So if you get a failure rate of higher than 20% of recent messages, this will stop the listener and pause it and try to restart it for, say, 5 minutes. Again, this is another way to build some resiliency into your system. Give it a chance to stop trying to push messages through some kind of distress subsystem. Let it pause, keep things piled up in a queue so it doesn't get lost, and it hopefully doesn't take any manual intervention to bring things going again. Okay, looking at the time, this always goes a little slower than you think. All right, so external messaging, I'm just telling you some of the things this supports. My own shop heavily uses RabbitMQ. That's what I've used, mostly what I've used in the last 5-6 years. So strangely enough, RabbitMQ is the most complete transport option, but there's also transport options brewing in a working state of all the basics for AWS QS and Azure Service Bus, with a lot more activity planned. Like today, it's not utilizing a lot of the advanced features of either, but that's planned. This is straight out of the documentation. I know you said the lettering is too small, but Wolverine's going to be able to talk, obviously, to other Wolverine applications. Potentially, you can take some control over how it understands and interprets the raw messages coming in, in terms of serialization or header structures. Right off the bat, it's interop. We have tested interop with mass transit and service bus. So again, doing a preview of this talk for my architecture team yesterday, and one of my colleagues kind of pointed out, naturally, so what? Why should we stop and spend 1.5 years replacing one of our existing infrastructure with this thing? And then I said, well, of course we wouldn't do that. We would never be allowed to do that, but we don't have to because of this interoperability mode. And we actually use both mass transit and service bus in different systems. We would be able to adopt Wolverine for new systems or one service at a time and use the interoperability model. Let me show that real quick. Coming back here, I'm not crazy enough to try to demo that today, but again, building a tool that we want people to actually use, and that means doing exactly this kind of thing to enable people to actually be able to adopt it today. So that was actually a lot easier than I thought it was going to be. Yeah, no real huge issues there. Okay, so say 10 more minutes before we stop for questions. So this is a big thing, and that's an actual Wolverine. So we may kind of ask, something we're talking about a lot in our own shop is how to improve our integration testing. Not just use Selenium as a golden hammer, but have some way to test our systems, especially when we have a lot of asynchronous messaging, where there's a lot of important processing happening across threads, happening across systems. So Wolverine, my theory here is Wolverine's signature by getting a lot of the framework goop out of the way. That it probably makes unit testing easier. But now I want to show what integration testing would look like. So if we are working completely in one system, only running one thing, but even in our request ride, we are trying to cascade a message that ride requested is being queued up locally. So there is, sorry. So there's a separate handler that tries to handle this ride requested event and figure out what drivers are possible. And then it's actually going to send, after it determines what riders could do this, it's going to try to send a message over to a completely separate service. Right? So there's a lot of stuff going on. Let's try to run this real quick. Just a second. Okay, so I'm going to spin up some new Docker containers. I'm going to spin up Postgres, RabbitMQ. If we have time, I'm going to show the built-in open telemetry. That system's not running right now, and that's actually okay. Let me make sure. Okay, that looks good. Another issue to make the testing work. Oh, I don't actually need that here. Sorry, folks. Yeah. Okay, 2 sets of tests. So in this case, I'm using XUnit here. Building your application, it's a little bit potentially expensive. So I'm setting up a shared fixture with XUnit. Using yet another tool called Alba. That's just a little helper for testing ASP.NET Core. The point here is this is spinning up the host for our application. You can see right there. So if you're familiar with that Web Application Factory, we're running that against this setup to get get this running in memory. So now we have the Alba host it's an iHost. So in our test itself, we're going to take in the shared fixture. So single test, I want to request a ride within one process. But in this one process, it needs to send the request a ride. We need to wait until all the activity is done. So request ride goes in, it saves a ride. It cascades a ride requested event. That's handled internally in a background queue. When that's done, it actually publishes yet another message. So what I'm going to do here, this is a little helper, this extension method. This is part of Wolverine baked out of the box. This is going to track all ongoing activity, and it's going to wait until it can tell everything is finished or time's out. Let's try the test. This worked last night, I promise. And here we go. It's not a very fast test. It's spinning up the host. It's doing that code gen in the fly, but we're up and going. While that's running, just show another option. Another thing I can do, I don't know how common this will be in real usage. Wow. Okay. I'm not going to spend too much time on that, but our test here, we were requesting, hey, there should be a notify drivers command sent out, and it didn't get there. So the testing, it's not just trying to coordinate the activity, it's also trying really, really hard to provide as much contextual information as possible about what happens. You can troubleshoot. This is strictly for integration testing. Yeah. Let me try this one here real quick. So this test, a little bit different. I'm actually building the other application in memory, again, as an iHost. I'm not sure a lot of people realize this. You can spin up multiple hosts in the same process. The only time I've ever done that is for testing. But I can set the testing up so that kind of tracking and coordination can happen across both applications. So both the main application, but also this downstream notification service. Oh, okay. And this one's failing because I said there should only be one notify drivers command. There's two in the queue. Let's give a little more context. That's the purpose of this thing right here, this auto purge on startup. I'm going to try this one more time and then quit. I love these slow tests. And woohoo, we pass. Okay, just to prove that something in Wolverine worked today. All right. So, and then we're running pretty slow on time. There's a big point I wanted to make here. Clone and go. Again, Wolverine's meant for grown-up development. One of the things we want, I know I want inside of middleware, excuse me, in Medi Analytics or any application I ever work on, I want to be able to be a new developer, walk in, do a clean clone from the Git repository, be able to immediately run maybe at most a Docker Compose file and start running tests. So in the case of this application, you did see me spin up a Docker container with Postgres, RabbitMQ, and Jaeger that we may or may not get to. Okay. When we did that, at no point did you see me run any kind of database script. You didn't see me run a database script. You didn't see me go into RabbitMQ at all. But let me just kind of show. I know you got to squint really, really hard, but there's a whole bunch of tables that pop up into this ride sharing schema. In development mode, this thing right here, a couple things. This little option here, this tells the Wolverine application that on startup, it should try to build any kind of what I call stateful resources. So RabbitMQ queues, RabbitMQ exchanges, build those on the fly on application startup. And also, by doing this, we've declared we want a certain number of Postgres database tables. When I started developing and building, combination of Martin and Wolverine was able to spin these objects up on the fly for us. So again, this kind of idea, general idea of do a clone, immediately get to working. Just going to say I'm running short on time. Wolverine comes with open telemetry completely out of the box. There's nothing you need to do. There's no explicit code to write. The only thing you would need to do is to set up the open telemetry exporters. And honestly, it could be a little simpler here. So I'm exporting the ASP.NET Core instrumentation. That's valuable. I'm setting up a Jaeger exporter, and this is important here. I just want to say I want the Wolverine OpenTelemetry data exported. So this gives you distributed tracing between processes with all of the correlation you're going to need to be able to understand what your system's doing in production. Because again, this is made for grown-up development. Very short in time, the very last thing I want to try to show, specifically the combination with Martin's event sourcing. And also, if you're curious, there was a recent Martin event sourcing talk through the JetBrains webinar about a month ago. So definitely go check that out from my colleague, Oscar. But combining Martin and Wolverine and what we're starting to nickname the critter stack or the critter pack. Specifically, what we're trying to do here is use the Wolverine middleware, the Wolverine messaging support combined with Martin's event sourcing. We're trying to create the most productive event sourcing plus CQRS framework on any technology stack, period. That's the ambitious goal. Not there yet, but here's a huge, I want to show a huge down payment on that today. So let me take a look at a little bit of code. Okay, so back to our ride sharing application. This time from the perspective of a driver. If I'm a driver, there's a candidate ride out there. I want to say on my phone, I want to accept this ride. Now we're using, I know I'm omitting a lot of details, but using an event sourcing workflow. What we want to do is accepting this command. We have an aggregate document that is the compilation of all the events that have happened to a single driver in a single shift. So you're just seeing the state of a driver, where they're at, what they're doing. You know, are they busy? Are they part of a ride? These methods here, this is seeing how this aggregate is mutated when different events are happening. So I've accepted a ride. My current ride ended. I'm ready for new things. When I want to accept a ride as a command, I need to get to the existing driver shift. You know, what's the current state of my world? I need to apply some concurrency protections here. If I issued this accept ride, knowing that this is an internal detail, we're going to use some optimistic concurrency that I issued this accept ride command based on version 11 of the driver shift. So if this driver shift has changed somehow, like maybe I'm using an iPad and a phone at the same time, I tried to do the same operation in two places somehow, we get a little race condition. We can actually check the driver shift has its own version, but it's using data stored in Martin. We can reject this if there's an optimistic concurrency violation, but do that automatically. But in the end, so that this whole command handler, go look up the existing driver shift, given this accept ride in the state of the driver shift, we are going to determine what new events should potentially be added to this driver shift based on what happened. So where we are getting to is something called the decider pattern, where we have a single method that just tells us, that's just asking what should happen next, what event should be emitted next to change the state of the driver shift and potentially also to send other things out. Using a middleware strategy here, you see this is completely a synchronous method. It's nothing but a state machine. We'll get into it. It's also possible to add add other external services from your container. Like I could do extra data lookup if I needed to. But for right now, simple method. This is something that I could easily write unit tests against. Then seeing the generated code just to be nice to see what we've done. This is using an outbox. So these events that are going out, one of these events would be driver inbound, potentially. So we're going to enroll, we'll create a Martin session that's enrolled in our outbound outbox. We are going to go fetch the driver shift from Martin. And when we do this, part of what this is doing, we can pick off what the driver shift ID is from the command. We can tell because it has a version. We actually enroll in the optimistic concurrency there. Finally, we call our method. We figure out what new events happen. We append those events. And finally, we save them to the Martin event store. But there's a little bit more going on there. So the last thing. Also got this going on. So automatically kind of listen in events being captured in Martin, and any event that is being captured where we know there is a messaging subscription in Wolverine's going to kick it out. That as well. It's a little bit of Martin setup. Can I Wolverine just to make that a little more clear? So one of the events that potentially gets emitted is driver inbound. Just all it means is the driver is left wherever they're at and they're headed your way. So if we have an active subscription that Wolverine knows driver inbound goes to this specific place, when I capture that event through that mechanism over here, that event is going to be also automatically published to RabbitMQ. You don't have to do anything else. Again, that may be a little bit of magic, but what we're trying to do here is reduce the work that you have to do as a developer to really just your business logic. We're not making you fiddle around with the data access, transaction scopes, even optimistic concurrency. We're just handling it for you here. So this is where we're trying to go with the combination, getting to this critter stack combination. And on that note, I've gone a little bit over. I'm going to stop and just ask if there's any questions.
Yeah, hi Jeremy. Thanks for a fantastic session there. That's a really good look at Wolverine, and I do get the whole feel for the low ceremony side of things there. It's looking really nice. We do have a number of questions. I think you've actually covered a few of them just in the last section there, but I'm going to go over a couple anyway. The first one really is, can a handler method cascade out multiple messages? So it's like one message in, but many out. And I think that's what you were perhaps showing in that last example there.
Yes. Yeah. So your signature here, instead of, yeah, I should have mentioned that. Yeah, you don't have to use yield, but if your signature is returning whatever. Yeah, if your signature is IEnumerable object, yes, 0 to many. Yep, absolutely.
Cool. And you just yield them, basically, isn't it? And so they just.
You could. You don't have to do that. You could return an array of objects.
I see.
Whatever's
Okay.
easier for you.
That makes sense. That's cool. A separate question then, the handle method you got there, and I think you just showed this as well. That's not a fixed signature, is it? It can be, you can inject other services.
Correct. So, yeah. So this other, I didn't get into this one very much, this other handler, but anything that's in any service that's in the container, where Wolverine knows how to get it, or there's a few specialized things where Wolverine knows how to fulfill it without going to an IOC container. So again, I don't think people are not everybody's going to like this, but you could say data time offset now, and it's going to push the current time or the cancellation token for the current message.
And the current time is useful presumably for testing, so you can mock it out. You can push in a. There we go.
Exactly.
Paying attention. A similar question, really, with the signatures. There was for error handling. You're showing some very interesting error handling stuff going on there. But can you kind of inject anything into those handlers?
Yes. Man, that's hard to get to. I think I have a documentation sample. But yes, so you can write, I think that is documented. You can write custom, internally it's called an I continuation. Your exception handling is if this happens, return an I continuation that carries out another action. That I continuation actually has full access to the entire Wolverine runtime, which also gives you access to the underlying IOC container for your app. So you could do anything. So it's meant purposely to be able to do things like send completely unrelated messages, send emails, send text messages, that kind of thing.
Do whatever you need it to do. Yeah, cool. Sticking with error handling as well, someone asked if the retry error handling middleware was in process. So what happens if the main process shuts down while there's still sort of failed events to be retried? Because there was a retry versus a requeue, I think, wasn't there?
There is. There's a separate requeue. There's also one I didn't show to just say, schedule this in 10 minutes. That's out of process. So in that particular, I think you just kind of asked me, European or Asian swallow. And I think I just flew off the bridge. I think I would have to research that. I want to say that the attempts would never get incremented, and it would still pick up, especially if you're using a durable inbox. But I think I would actually need to go research that.
So the events would probably still be persisted, so you wouldn't necessarily lose anything.
I think so, but I'm not confident enough to say yes.
Sure thing. And then again, sort of again with error handling, what about reporting on that? How do you know when things are being requeued and paused and so on?
So everything like that is logged, and all the logging is using structured logging. So not that I remember exactly offhand how to utilize that, but if you're using like something like SQ, I think you could write your own reports off your logging.
It's all in there. Sounds great. Moving on then, can Wolverine bridge across transports? For example, consume a message from SQS and cascade out to Rabbit?
So yes, you need to write a little bit of explicit right now. So there's nothing like the out of the box bridge thing. I think in Service Bus does, but you could connect to multiple transports in the same app. Listen from one and publish to the other. It wouldn't be super automatic, but yes, you could do that with a little explicit code.
Okay, sounds good. And I think perhaps the last one then, is it possible to use a Fluent API for instrumentation of command handlers instead of being forced to use attributes?
Yes. Well, okay, yes and no. Fluent interface in the standpoint of using, I'm sorry. I had to think about this for a minute. So you do have policies where you could say, I want every handler to have this. So you're talking about applying middleware. You can use policies to do it at large. There's some programmatic ways where you could put it in a handler itself. You could use some programmatic code to do that as well, to do that explicitly. It's not exactly a Fluent interface, but I think that covers. So this kind of framework, you usually have some kind of underlying semantic model. That's the configuration model of this handler has this middleware in this order, that order. And that semantic model can be worked with directly. So policies, attributes, explicit code, all of that is, in the end, is configuring that semantic model. You have fine-grained control in Wolverine to monkey around with that. Now, whether you should or not, how far to go, that's yet to be determined.
Mm-hmm. That sounds good, though. That sounds like you got access to everything you need, really, which is brilliant.
You got enough rope. You got enough rope to hurt yourself.
That's just the right amount of rope, I think. That sounds good. Finally, actually, then, last question. You mentioned something about Daniel Marbach's blog posts. Do you happen to have any more detail of what we could search for to find those?
Give me 1 second. It's, on one hand, I absolutely want to praise him because he's done some crazy smart stuff, but also poke just a little bit that Wolverine sidesteps all the problems he had to solve.
I think it's the interesting geeky details are fun to dive into with these things.
Yeah, so let's see. Is my screen still up?
Yep.
Yeah. Oh, hey, look at that. Look where he did it.
Well, wouldn't you know it?
Yeah.
That's fantastic. I hadn't realized I thought it was a blog post rather than a video. I missed that. So that's great. Yeah. So what a wonderful segue. Yes, we've just recently did the JetBrains .NET Days online, and Daniel did a brilliant presentation there, which I clearly missed. He's going to thank me for that. But yeah, you can go onto JetBrains.tv and find that there. Then that makes that nice and easy. Okay. That wraps it all up for the questions then, Jeremy. So that just leaves me to say a big thank you very much. It's been a very, very interesting session. And let me just pop up this last slide then for a bit more information. If you want to get more information about Wolverine itself, there's the GitHub site. Obviously, there's Jeremy's Twitter and website there as well. And we'll obviously leave some posts there for Ryder. But Jeremy, thank you very much again for a fantastic presentation.
Thank you so much for having me. Thank you to everybody that came, and thanks you for all the questions.
Yep, exactly. Thanks for the great questions. Again, there's more screencasts such as Daniel's available on JetBrains TV channel there. Please subscribe, and there's plenty more coming. So thank you very much, and goodbye.